right, well, I trust you did well on your test. Students in here did very well, very pleased with how the class did on their test over graphing and some introductory algebra. We're going to be talking in just a moment about one of my favorite things in math. I love solving equations. And my little girl, Chloe, she takes after me a little bit, and she's in 3rd grade, and they just started doing some semblance of really easy equations, and she just loves it. She wanted to make up her own equations, and Daddy, pick a number, and and she'd write a little equation or whatever, and so we're going to get into that here in just a little bit, but first we need to understand something called an inverse property. An inverse property. Now we remember we talked about the commutative property earlier this year, right? Water bottle. If we add two things, we can swap the order and it doesn't matter. If we multiply two things, swap the order, it doesn't matter. We talked about an associative property where we can group different things, right? And so we can work things out of order by grouping if we wanted to. We talked about a distributive property, which we'll come back to in a little bit. But we hadn't actually talked about an inverse property. If you want to write this off to the side margin of your book on page 444, so if you're watching on YouTube, go and turn to page 444. Students in here are already there. If you'll write in the side margin next to the review section, inverse property. Inverse property. An inverse property is anything that results in canceling. And when we cancel stuff with addition or subtraction, we can get zeros. Right? If I give Luciana $10, y'all be like, he playing favorites now. But if I take the $10 right back again, she's very confused and y'all feel better about the whole thing. She just feels confused. Well, what I did, I undid my favoritism. Gave her $10, favorite student. Took the $10 back to regular status. Okay, so anyway, but that would be an inverse action, right? Give 10, take 10. So if I came to Corey, I'm like, snatch his pen away. He's like, it's okay, I borrowed it anyway. Just kidding. But if I take his pen, oh, you're a thief. Okay, then I give the pen back. Okay, I'm not a thief anymore. I'm just a very confusing teacher. Okay, well, that's an inverse action, right? To take and give back. So, adding or positive and then subtracting or negative cancels out to nothing, right? Or taking negative or subtraction and then adding back positive the same amount would cancel out to nothing. Look in your book there at page 444, number 29. If I have a 4, what would have to be added to a 4 to cancel it and make a 0, class? A -4. Similarly, on number 30, what would have to be added to an 81 to cancel it to a 0? A -81. Number 31, if we have a 23, what would I have to subtract to get 0? Another 23. Right? If we want to think in terms of sign numbers, subtracting a positive is the same as adding a negative, which is what we've just been doing. But if I subtract the exact same thing, I go back to 0. Look at number 32. If I have a -4, what would have to be subtracted to get a 0? Another -4. If you think about adding the inverse, it would be the same as adding a +4, which would cancel the -4. But if you subtract exactly what you start with, it's going to give you 0. In multiplication, though, we don't cancel to get zeros. Y'all know this, right? Because when we worked problems and we had something like a 3/5 times 7/3, like, hey, the 3's just cancel cleanly, right? Well, they don't give you zeros, they give you 1s. When you multiply and cancel, the inverse property of multiplication says you can multiply by a reciprocal. A 3 in the numerator would cancel with a 3 in the denominator. 7 and 5 wouldn't cancel, but what could I put here, class, to cancel with the 5? Another 5. They would cancel, and my answer would be 1, right? So if I multiply by a reciprocal, it cancels out. So as we look at number 33, what would cancel with a -4 through multiplication? Well, in your book, you've got the -4 in parentheses. Put it over 1. Right there in your book, go and put it over 1. What would have to be multiplied by -4 over 1 to produce a 1?
1 over -4.
A 1 over -4 or a -1/4. But you could put the negative in the bottom, I suppose. Later on I'll teach you that the negative goes in front of the fraction, but we don't have to worry about that right now. But yeah, the exact reciprocal. If this is a -4 over 1, a 1 over -4 or -1/4 would cancel to give a 1. So on number 34, what would multiply by a 2/3 to get a 1?
3 to 2.
A 3/2, a 3/2, right? 3 to 2 in that blank. What about number 35, Joel? What would I have to multiply by -7/5 to get a to get a 1?
-5/7.
-5/7. There we go, my bad. Number 36, what do we have to multiply 8 by to cancel and get 1? Bryson?
-8. Oh,
No, I would add a -8 to cancel to get 0. But what would I multiply to cancel and get 1? What's the reciprocal of 8? Tell you what, put a 1 under your 8. See where it says 8 times? Under the little 8, put a 1. Maybe that'll help you to see it. 1/8. There we go. What would we multiply a -1 by to get a 1? This one's a little tricky. Luciana?
-1.
Another -1, because it is its own reciprocal, right? For instance, if you put that one over 1, that's -1 over 1. We'll multiply by 1 over -1. It's still -1. What about number 38? Corey, what would we multiply a 5 by to get 1?
1 over.
1 over 5, or 1/5. What about division? Well, what would we have to divide a 12 by to get 1? Elaine?
No, -12?
No, that would give me a -1 because the signs would be different. So,
12.
just 12, right? If you divide something by itself, it gives 1. So 12 divided by 12 would give 1. So similarly, Elaine, stay with you on 40. What would we divide a -6 by to get 1?
+6.
Because then you'd only have one negative, which would give me negative. If I want the positive, I need another negative to cancel it. So a -6. Does that make sense, this idea of an inverse? Because inverse really plays a huge role in solving equations. Flip back now, if you would, to page 440. And let's talk about solving equations. It's one of my favorite things to do in math because I like solving puzzles. There's something satisfying about working your way through a problem and figuring out what x is equal to. And it's just a few things to note here. If you will, write this down or mark this. It's actually in the first line of the text. An equation is a mathematical statement that uses an equal sign. It's a mathematical statement that uses an equal sign. If there's an equal sign, it's an equation. If there ain't no equal sign, it ain't an equation. What we were doing earlier before the last test, right, combining like terms, we weren't ever like solving for x. We were just combining a bunch of terms that had x in them, or m or p, or maybe p squared and p to the third. We were combining stuff, but we weren't actually solving anything. With an equation, you have to solve something. You have that equal sign in there. And generally, there is one letter in that equation called the variable, and your goal is to figure out what it is. For instance, let's do an equation like what Chloe might do in 3rd grade. X plus 3 equals 10. Well, Chloe could ask herself, what plus 3 equals 10, class? 7. The goal is to get an answer that says x equals 7, right? It's not solved yet because x isn't yet by itself. That's really your key. Right there in the side margin of your book, and put a little star next to this. The key is to get the variable, get the letter by itself. The key is to get the letter by itself. The book has this in bold, isolating the variable. That's fancy talk for get the letter by itself. Isolating the variable. Get it by itself, which means everything else with it got to go, right? So if, let's see, Corey, you've got 3 brothers, okay? Now, Corey's the youngest, so usually the youngest doesn't have the power or authority in the hierarchy to get rid of all the older siblings. He just has to wait till they graduate. And that's about to happen, right? So you're about to have the house somewhat to yourself here. But in the meantime, if somehow Corey somehow assumed power that the youngest child generally does not have, right, Griffin? You feeling it? The not having any power? Okay, but if he wants to get by himself, he doesn't leave his room. He gets everybody else out of his room, right? So, in this equation, this equal sign is like a wall. Everything here is all together. And if we want the x by itself, do we see that the 3's got to go? The 3 is with the x. If we want to get the x by itself, we don't get rid of x. That'd be silly. We get rid of 3. This is like the annoying big brother who just won't leave you alone. That doesn't sound right. It's always the little brother who won't leave the big brother alone. But anyway, for sake of our illustration here, it's the annoying big brother who won't leave little bro alone. How do we get rid of this? Well, we do something they don't like. Right? Now, that's not good parenting, okay? So no, parents won't appreciate that. But practically speaking, you know this, right? If they're in your room playing with something or whatever, you do something mean to them to get rid of them, right? You do the opposite of what they like. Well, here, do we all see we got a positive 3 or a plus 3? Well, let's do something contrary. Let's do an inverse operation. What's the opposite of plus 3 or positive 3, class? Negative 3 or minus 3. Bam! They cancel to give you nothing. We just saw that in the review exercise. X is by itself. Corey has his room all to himself. It's like the little one said, roll over, roll over. And then when you get to the end, they all fall out of the bed and the little one's all by himself. And the little one says, I got the whole bed too much. Anyway, I have little kids, I'm sorry. But here's the deal, right? In an equation, we can't just randomly kick things out and get rid of stuff. Like, that's mathematically erroneous, right? It can't be like, you have this big old equation like, yeah, I'm going to just cut all that out and be like x equals 2. You can't do that, right? There's a right way to do things. So you see this in bold, right above that little scale thingy. What is done to one side of the equation must be done to the other side. Mark that, highlight it, put a star next to it. The way I say it is what you do to one side, you got to do to the other side. So we want to put a minus 3 or a negative 3 here. Bam, it's gone. X is all by itself. Got the whole room to itself. But what I do to one side, class? Got to do the other side. How many you remember here in that in arithmetic class the last few years? Yes. What you do to one side, got to do the other. So I got to put a minus 3 on the other side as well. And of course we know class 10 minus 3 is 7. And once the letter's by itself, we're done. We have solved. We know that X is 7. Now, we knew it before we solved it because it was an easy one, but we get that idea. Now, the only thing is, we ain't in 3rd grade no more. So we aren't working equations like this no more. We're working equations that might be a little bit more complicated, not crazy complicated, but look at the top of page 441. It says x minus 6 equals, whoa, what are they doing? Negative 4 plus 14. So one of the keys is, right, this is at the top of page 441, simplify first. Simplify first. I like this equation just fine because there was one nice easy number on the other side. I don't have one nice easy number on this. Well, let's make it one nice easy number. What do we get if we combine a negative 4 and a positive 14, class? We get a 10. So x negative 6 equals 10. Just combine. We know how to combine numbers, right? Signs are different, so try to keep the sign of the greater absolute value. Now we're ready to get the x by itself. Class, if this is the wall, what is with the x? What is annoying the x right now? It's not a 6. It's a negative 6. So to get rid of something, I got to do the opposite, right? Do the opposite of what it likes. It's all negative 60, right? Well, the best way to get rid of somebody who's grumpy is be sunshine and happiness around them. They don't want to be around you because they want to be grumpy. There's a grumpy 6. There's a grumpy big brother. So Corey's just all cheerfulness and sweetness, and they can't stand him, so they leave. Let's get rid of our minus 6. Class, what do we put? Positive 6 or plus 6, but I like the way of saying positive 6 better. And what happens to these two inverses, class? They cancel. You're going to cross it out. There's a satisfying feeling of crossing stuff out. Head off hand, good posture. But what do I do to one side, class? So I got to put a plus 6 on the other side as well. Well, now the x is all by itself, and it equals 16. Questions on solving equations. Seem pretty easy. All right, flip over to page 442. Flip over another page. I want you to do 1 through 6 at the bottom of the page. Page 442, numbers 1 through 6. Simplify, get the x by itself. And you'll have it solved. Try to keep it easy here at the end of the year. Don't want to blow anyone's brain. Into May now. There's only so much brain power left. let Corey come to the board with the first one. Joel to the board to the second one. Elaine to the board to the third one. Corey to the fourth one. Joel to the fifth one. So Corey, take the one in between you and Joel. It's not. I think the way you're approaching the problem is a little tricky. So let's do this. I think what'll help you a little bit here is if you'll go ahead and rewrite the s minus 9, and you know you multiplied to get something here. Go and write that right there. So it just kind of keeps everything neatly lined up.
Okay, so that.
There we go. Now on both sides, write the. Now you put a plus 9 here. Well, go ahead and put it right there in both spots. Now you're able to see what you're working with a little bit more.
Okay. So
Excuse me.
there we go.
Ish, except 15 minus 9 isn't 6. Or isn't 7, it's 6. 16 minus 9 would be a 7, so then the negative 16 would have been a negative 7. There we go. All right, have a seat. All right, pencils down. Look up this way. Let's take a look at these first 6. Your first shot at some equations this year. And on the very first equation, I like how nice and neat Corey was. He just combined his 6 minus 1 negative 5 and recopied the x negative 3. Then right below the minus 3, plus 3, plus 3. Keeps things nice and neatly lined up. That cancels, so he's got x. 5 plus 3 is 8. How many also got 8 for the first answer? Number 2, Joel recopied a plus 1 and recopied this to get a 5. Then he put a minus 1. I would have liked to see just go straight vertical here, Joel. You go vertical here, just go vertical here, be a little bit easier. And then you get 5 minus 1 written the way we're used to seeing it. A equals 4. How many had A equals 4 for number 2? On the third one, Elaine multiplied the negative 3 times 5 to get a negative 15. Then she put a plus 9 on both sides, and negative 15 positive 9, when you subtract, keep the sign of the greater, gives us negative 6. How many had negative 6 for number 3? Number 4, the first thing that Corey had to do was square the 4 to get a 16. Then he could do the 16 minus 15 to get a 1. And he just kept everything nice and neat. Recopied the r plus 5 in both cases. R plus 5 equals 1. Then he put a minus 5 on both sides, and we have a positive 1, we have a negative 5, r equals negative 4. Great job. How many had that on the fourth one? Negative 4. Be careful with negative signs. Look at the next one. Also Corey? Corey went ahead and combined 12 minus 10 to get 2, and of course 2 times 2 is 4. So we had 4 equals b minus 7. He put a plus 7 on both sides to get 11 equals b. But Corey didn't want to write 11 equals b, so he wrote b equals 11, and that's fine. Remember, an equal sign just means they the same. So if you write 11 equals b, correct. If you write b equals 11, also correct. If it really bothers you to have the letter after the equal sign, how many had one of those answers? 11, basically, as your answer for number 5. And then on number 6, Joel combined negative 5s to get a negative 10. I'd like to go ahead and see you cross out the 9 to 6 plus 6 to show that they cancel. So he left him with a y. I like that he kept that equal sign neatly lined up. Negative 10 plus 6 gave him negative 4. When you subtract, keep the sign of the greater. Great job, Joel. How many had negative 4 on number 6? Questions on any of these? You say, can you go over that one more time? Because you lost me a little bit there. Anyone go 6 for 6? You got them all? Anyone 5 out of 6? You only missed 1. 4 out of 6 just missed 2. All right, the ones that we missed, the 1 or 2 we missed, do we understand them now that we've seen it explained? All right, then go to the next page and do 7 to 15. Go to the next page now and do 7 through 15. And neatness is going to be a big help in this. So you can keep that equal sign lined up. It's going to help keep things nice and neat for you. You'll notice on number 7 class, the like terms that have to be combined are the two x terms, aren't they? We're used to combining over here in the first problems. They give us this one. Well, what is 5x minus 4x, class?
1x.
Just a 1x. Or, do we have to write the 1, class?
No. Just a-
X.
Just an x. And so it makes the problem kind of easy there. So did want to point that out because that's the first time we've seen them have to combine x's together. But we should be good with that, given what we were just working on.
That's not suspicious. You just hackers to finish at the same time.
We're on page 443, working on solving equations. So fun stuff, yes. My favorite part of math. I love solving equations. They're so much fun.
That
Right,
adds
Michael?
up.
What?
That adds up.
All right, so real quick, the rest of you keep on working. Michael and Jalen, I want you to look up this way since you just came in. As we solve equations, the ultimate goal of an equation is get this. X equals, P equals, W equals. The letter all by itself, right? That's the ultimate objective. Get the letter all by itself. Well, in this first problem you see up here on the board, we have two different x's, right? There's a 5x and a minus 4x. Well, that's just combining like terms. Jalen looking up this way. We know how to combine like terms. 5x minus 4x, that's just 1x. Or, we don't really have to write the 1. We just said x. Plus 2 equals 1. Notice I keep everything neatly lined up. And it says, well, I want the x by itself. I said to the rest of the class, imagine a wall right here at the equal sign. This x is not by itself because in the same room with it is this plus 2. Well, we can't solve the equation until that plus 2 is gone. How do we get rid of a plus 2? Well, we get rid of something by doing the opposite. The opposite of plus 2 is minus 2. They're called inverses and they cancel. So that just leaves us with x. But what we do to one side, got to do the other side. You remember that from earlier in your elementary years. So we also put a minus 2 or negative 2 over here. Well, now we're adding signed numbers where the signs are different. Subtract, keep the sign of the greater. Over here, I had a bunch of stuff going on over here on the right-hand side. So we just got to start with 5 squared. Okay, that just becomes 25. Everything else nice and neat. Well, 25 minus 13, I can combine that to get a 12. Everything else nice and neat. Now I'm ready to get the p by itself. The opposite of plus 10 is
Negative 2.
minus 10 or negative 10. So put a negative 10 on both sides. Positive 12, negative 10 gives positive 2. So we look at this one. Well, I got parentheses. Take care of that to get a 9. Well, then I got multiplication. Take care of that to get 18. Then I got subtraction. Take care of that to get 17. Once you've simplified that other side, now we can get the w by itself. It says minus 5 or negative 5. The opposite of negative 5 is positive 5. On both sides, w equals 22. Makes sense? Just keep it nice and neat. Okay? So pick up there on number 10. There on page 443. While I was going over that, questions, and how many of the rest of us at your seats, you got these 3 correct? That top row you were perfect on? Any questions on the top row? I'm going to go ahead and erase them now. Any questions, top row of problems? Anyone need me to leave them up so you can have just a little longer to look them over? Okay, I'll leave them up for just a little bit then. Right, so we just got to finish by putting the -2 on both sides. All right, for sake of time, pencils down, look up this way. I know not all of us have had time to finish, but we're kind of up against it here. So let's take a look at some things here. Notice in this problem, it's the right-hand side that needs to be simplified. I've got a negative 40 over 2. Class, what does this fraction bar mean? Divide. So I'm dividing a negative 40 by 2. Well, 40 divided by 2, class, is 20. But if there's a negative divided by a positive, it's negative 20. And then I had to get the z by itself. Ignore the negative 20. I know some of us might be like, ooh, I put a positive 20 on both sides. Why? If this is the wall, the negative 20 ain't bothering the z at all. What's with the z, class? The negative 11. That's the problem. You identify what is with your letter. Whatever's with the letter, it got to go. Get it out of here. So we get rid of the minus 11 by putting a plus 11 or positive 11 on both sides. And with negative 9 equals z, or if that bothers you, you can write z equals negative 9. How many had that for number, whatever that was, 10? All right, questions on that? Does it make sense now? Looking at the next one, everything's already simplified. I literally just have to get rid of this plus 1/5, so the m will be by itself. Well, the opposite of positive 1/5, class, is negative 1/5. That's the inverse. So put negative 1/5 on both sides and get m equals 2/5. Somebody had that for number 11. On number 12, what do I have to do first? Luciana?
You got to multiply 2 and 14.
2 times 14 should give me what over here on the right side?
28.
28. Now, what do I got to do to get a by itself, Luciana?
So, we'll add the inverse.
Which is
Negative 12.
negative 12. You could say minus 12, and that's okay, but I like negative 12 better. Put a negative 12 on both sides, and that gives me a, all by itself now, equals 16. Great job. Looking at number 13. What do I need to do first on 13? Elaine?
You need to do the 7 minus 5 is 2.
There we go. Just simplify 7 minus 5 equals 2. No big deal there. Now, what do I do to get n by itself?
Then negative 13
On
cancels out.
both sides,
Yeah.
right? And so here it cancels to get just n. On this side, positive 2, negative 13?
Negative 11.
Negative 11, great job. How many had that for number 13? Number 14, we've got a t minus 20 equals, well, when I simplify the other side of the equal sign, Bryson, what is negative 6 times negative 5?
30.
Positive 30. Now, Bryson, what do I do to get the t by itself?
You add plus 20.
A positive 20 or a plus 20 on both sides. That's going to cancel with the minus 20. The t is now all by itself. What do I get on the other side?
T or 50.
T equals 50. Great job. How many have 50 for number 14? Oh my, number 15. Oh, Mr. McCaskey. 0.4 plus c equals 1.6. How frightening. Well, class, what's with the c? 0.4. Now notice, class, it's an understood positive 0.4, right? I'm too lazy to write the 0, by the way, if that's your question. But it's a positive 0.4. How do I get rid of a positive 0.4, class?
Negative 0.4.
Negative 0.4. Bam, it's gone. C's all by itself. But what I do to one side?
Good.
So I'm going to put a negative 0.4 on the other side to get what for our answer, Griffin?
1.2.
Oh, positive 1.2. How many had it, those who made it that far, had the 1.2 on number 15? All right, questions on any of those 7 through 15? Questions on any of those 7 through 15? I want you to tackle that next row, 16 to 18. Tackle that next row, 16 to 18. Simplify the side that doesn't have the letter, then get the letter by itself. If there's anything on the letters side that can simplify, and there usually isn't right now, we would simplify that too, but mainly focus on simplifying the side without the letter. Michael, what do I need to do to simplify the non-letter side, in this case, the right-hand side?
Well, you add negative 5 plus 2.
Good, because remember, a fraction bar is a grouping symbol. It's just the same as if this were in parentheses. I do that first to get 5 over 3. Now, can I divide a 5 by a 3, Michael?
No, so just leave it.
Just leave it as 5/3. But this other side, I just neatly recopy d minus a third equals 5/3, or d negative a third equals 5/3. I'm actually ready now to get the d by itself, Michael. All I have to do is put
Positive 1/3.
on
Yeah, both sides.
both sides. There we go. And that'll give me d is equal to
6/3.
6/3. Wait a second. I know what 6/3 is, class.
2.
It's 2. So our final answer, even though there's all this nasty looking fraction stuff, the answer just is 2. How many got 2 for this one? That was kind of tricky. They had some ugly stuff in there to mess you up. And several of you not fooled. Look at the next one. Joel, what do I have to do first?
So you have to do the right side.
To get?
10.
Positive 10. Good. So we're going to keep the v minus 2.8 for now. Just simplify to get the 10. Now we're ready to get v by itself. What do I have to do to get v by itself?
And positive 2.8. And on both sides.
Now, right here, it wouldn't hurt to add a 0.0 to the end of the 10. You don't have to, but it wouldn't hurt. Joel, our answer,
12.8.
12.8. Stay with me. How many got that answer on number, whatever that was, 17? Looking at number 18, what do we need to do here, Jalen?
You have to add the inverse. Never mind, do the inverse. Wait.
Which side should we start on, the left or the right?
The left side.
Let's start on the left side because it doesn't have the letter on it or the variable on it. Let's simplify a negative 5, positive 8.
3.
Positive 3 is equal to j positive 15. Now, Jalen, what do we need to do to get the j by itself?
Now you do the inverse. Negative 15.
On
Both sides.
both sides, good. So I've got the j all by itself, it's isolated. Now over here, negative 3, positive 15,
Negative 12.
negative 12. How many had j equals negative 12 on number 18? You're going to be practicing with some of these tonight. You'll also practice some of that inverse stuff, and there will be one problem to challenge you a little bit as well. Curious to see how we do on that. You're only doing page 444. Page 444, 2 to 24, the even. Page 444 in the homework section, 2 to 24, the even numbered problems. You will need to work most of them on paper. A lot of times there's room in the book. They did not give you room in the book. So you're going to need to do these on paper so that you have room to work it out and room to follow along in your work as we go over these tomorrow. All right, have a wonderful rest of your day, and you are dismissed.